It turns out that there are two totally different ways of thinking about what a parabola is or defining what it is. The first, of course, is that it's the graph of any quadratic function, any function that has x squared as its highest degree term. And I have one graphed here, y equals 1/8 x squared. So one way we could think of this is all of the points where the y value is the same as 1/8 of the square of the x value. It's that set of points. And that's the more common way of thinking of it. But there's also an entirely different way to conceive of parabolas. And it's this definition that I put in blue here at the bottom. A parabola is the set of points that are equidistant from a line, which we call the directrix, we'll get to that in a moment, and a point not on that line, which we call the focus, and we'll get to that in a moment. A parabola is the set of points that are equidistant from a line and a point not on that line. And you can see here, I have this point 0, 2, I have this line y equals -2, and I have the parabola that should, if this definition is correct, that should follow this rule. So let's look at some of the points. We can start with the vertex, where the distance from that point is 2, and the distance from that line is 2. Okay, so we're in good shape there. We can also look at, let's say, this point. The distance from that point is 4. The distance from that line is 4. Now, those are the two easiest points to check, but we could even look at, let's say, some point over here, and we won't get the exact measures, but we can draw some lines in here and at least see if it looks right. So here's the distance from that line. And up here, let's make sure we go to the focus. Here's the distance from that point. And yeah, we can see that the distance from the line and the distance from the point are the same. And that would be true of any point that we checked on this parabola. So it's the same line, and it's still defined by y equals 1/8 x squared, but it's just a totally different way of thinking about it. And we can check this. I'll put up another example here. So let me remove that one, and I'll put up, this is going to be a steeper parabola, and I'll get rid of these notes that we made for that one. And we can check again and notice, just as far as patterns go, that bringing the focus, so that's this point, and the directrix, this line, bringing those closer together produces a steeper parabola. But let's do the same kind of check here, and I'll actually zoom in so that we can go by ones here. Is that going to work? Well, that's okay. We'll at least get a closer view. So we could check again here. That's half a unit from the directrix. That's half a unit from the focus. So that's a good start. And there's not too many super easy ones we can check. This looks like an easy one because it's at an intersection, but well, let's at least draw and see if it looks right. We've got that distance from the directrix, that distance from the focus. We can at least eyeball, and we could prove this if we needed to, but we can at least eyeball, yeah, those look like the same distance. And of course, this would be true for every point on this parabola as well. So we have this new way of understanding what a parabola is based on this definition. And now we also have these vocab terms that I'll put up here. This is the directrix. So it's a line. In this case, it has the equation y equals -0.5. And we have the focus in various shapes, some of which we'll do, some we won't. A focus is a point that a graph or a shape goes around. A vertex is something that it goes through. A focus is something that it goes around. So you'll never go through a focus. And in this case, the focus, or in any case, the focus is just a point. So here it has the coordinates 0 and 0.5 or 0, 1/2. And the thing that we might want to know here is how this distance, which of course is the same as this distance, how that relates to the shape of the graph, the equation of this parabola. And in this case, we're looking at y equals 1/2 x squared. We want to know how those things go together. And there's a simple formula that relates them. And this is going to be kind of the formula for doing all this stuff. And just to remind ourselves, when we're graphing a parabola, we call this A. And remember, that was the amplitude. The higher number that is, the steeper the parabola is. And if we compare these two, you'll notice the one that had 1/8 as A was much shallower, and the one that had 1/2 as A was much steeper. Okay, so that's A. And the formula that we want to know here is, and we're going to call this distance C. So C is the distance from the vertex to the focus, or from the vertex to the directrix. And the big formula here finally is A equals 1/4C. And just to be clear, this is not, it's not A equals 1/4 C. So this is C in the denominator specifically. Be careful of that, because they'll give you completely different answers. And let's look now at these two that we just graphed and see how this little equation will work. So I'll start with the one that we've got right now, which is y equals 1/2 x squared. So A is 1/2. To find C, well, we know that whatever A is equal to 1/4C. And so according to this, well, we could do a couple. We could cross multiply. You might be able to just visually kind of see what the answer is. But if we need to, we can cross multiply. 4C equals 2, C equals 2/4 or 1/2. And sure enough, that's what we see here. The distance between the vertex and the focus, or between the vertex and the directrix, is 1/2. So that formula worked. Let's go back to the other one that we had graphed here a minute ago and try it with that, and we'll see that this works as well. So let me clear up that. And why don't we do it backwards this time? We will start with C, and we can tell that that's 2. C is always defined as a positive number, so it's a positive number in either direction here. And according to this formula, A for this graph should be 1/4 times, and we know what C is. In this case, C is 2. So A should be 1/8. And sure enough, that is A in the graph that we started with. So this little formula is the key thing when we're looking at quadratics, and I should say parabolas, this way. One more thing we should talk about is what the focus and the directrix really do. So one thing that we've seen is that the closer they are together, the more steep and more narrow the graph will be. To look at the directrix specifically, the directrix determines which way the graph opens. If you have a directrix that's vertical, which we will have, then the graph is actually going to open horizontal, like that. And you can imagine, although we won't do these, if you have a directrix like this, now the graph is going to open sort of diagonally. And so the directrix is called that because it determines the direction that the graph will go in. I suppose one more that we might do is if the directrix is above, then the graph is going to open down. So the directrix determines what direction the graph goes in. The focus, as we mentioned, it's a point that the graph goes around and not through. But here's one sort of neat property of a focus. By the way, the plural is foci, if that ever comes up. So here's one neat property of a focus. And let me make some room here. That is actually, I suppose, a real world application. think about a satellite dish for a moment. If you've seen a satellite dish, they're sort of wide and shallow, they're curved inwards, and there's a little receiver that's right in the middle of the satellite dish. And the way a satellite dish works is it gets signals coming in from wherever, and those signals all bounce off of the surface of the satellite dish, and they're all directed exactly towards this one point in the center where the receiver is placed. Well, this is actually a property of a parabola, that for parallel incoming waves or rays or whatever you have, they will all reflect exactly to the focus. So one application of foci in real life is if you're designing a satellite dish or something else like that, then all of the rays, the waves, whatever's coming in here will always be reflected exactly to the focus, and that's where your receiver goes. The opposite of this, incidentally, is a flashlight. So a flashlight, of course, you have light that's emanating from this point. The inside of the flashlight bowl or container or dish, whatever you want to call it, is reflective. And it is also in the shape of a parabola, so that all the light that comes out, and just imagine going backwards on all of these arrows, all of the light that comes out reflects perfectly parallel. So if you have a perfectly designed and perfectly functioning flashlight, all of the light comes out pointed directly where you want to go, straight ahead, no matter what angle it originally came out of the whatever's emitting the light in the middle. So there actually is some kind of neat stuff that these parabolas and that the focus in particular relate to in real life. But for us, for graphing, for understanding them, it's that one formula, A equals 1/4C, that's going to determine just about everything that we do with these.